Right, so in this one, we've got a slight variation that we're compounding monthly. So let's see what that changes. Our initial one is still a equals p1 plus I to the n. And let's fill in the bits that we seem to be giving. 50,000 is deposited, so that's our initial amount. 1 plus equals. We've got, let's pause on the, just see it accumulated to 88,000. Okay, 88, 215, 14. Okay, so now let's read a bit more carefully. 50,000 was deposited into a bank account and left for 6 years. Now, okay, left for 6 years. At the end of the 6-year period, it accumulated to the amount of 88,215 Rand and 14 cents. So that's what we got so far. If interest was compounded monthly, determine the interest rate per annum. So we don't know what the interest is. This is what we're going to work out. But think about when you work this out forwards. You wouldn't have just put I. You would have put I over 12 because it's monthly. And our compounding periods, the number of periods is not 6 because it's not 6 years. But we've got 6 years compounded monthly. So it's 6 times 12. Let's just do this on the side here. 6 times 12, 72 months. So this is to the power of 72. So that's the only key difference here. I over 12 because it's compounded monthly. And our compounding periods is 72, which you would have done if you did it forwards. Okay, now this is going to be similar to the first example we did. We're going to divide both sides by this 50,000. Okay, 50,000, 50,000, so that those cancel out. And we'd have, let's do it, 88215,14 divided by 50, 1, 2, 3 equals 1,76, what? Not worried about anything yet, keeping it in the calculator. That's 1 plus I over 12 to the 72. Okay, next up, 72th root, right? That's what we did last time, so we're going to take the 70th to th root on both sides. So, shift root 72 of aunts. Okay, so what I'm doing there in the calculator, let me move myself out the way here and say I'm going the 70th to root of aunts because this bit is in aunts, is 1,76. Okay, so we get, again, let's squeeze ourselves up here, and we have 1,0079 equals 1 plus I over 12. Okay, let's keep going. Minus 1. So minus 1 equals. Now, I get some funny looking number here. And it says 7,9 times 10 to the minus 3. This is what my calculator says. It goes 7,9166 times ... times 10 to the minus 3. Because it's such a small number, it's telling me in a kind of an engineering way. Okay, so that equals I over 12. So either we can leave it, or if you wanted to see that as a number without that times 10 to the minus 3, there's an ENG button. So again, let's move out of the way here and say there's an ENG button on the calculator with an arrow. And that lets you cycle through in powers of 10 to the 3. So if we press it, it's going to go times 10 to the 6 minus 6 times 10 to the minus 9. Wrong way. So let's use the arrow part. So I just want to highlight that so we can go shift ENG, shift ENG, shift ENG. And then it says times 10 to the 0. So it just tells us that number if we wanted to see it as a decimal without the times. So at the moment that number there is, I'm not liking that light blue at the moment, 0,00791. That's what that number is. But whether you did that now or not doesn't really matter. What really matters is that in the next step, we just times by 12. So let's go times 12, so that on the right hand side we just got I. What we do on one side we do on the other. Times 12 equals, and it says 0,095. So the interest rate is times 100. 9,50% per annum compounded monthly. Compounded monthly. Yeah, so there it is. So only little trick there was this part right at the beginning. Remember, it's compounded monthly, so that amount, and then just if it looks a bit funny on your calculator, there it is.